This is a Stirling engine. It has a big cylinder with a foam element, piston essentially, that moves up and down inside the cylinder. And it also has a small cylinder. And you may be able to see that this one, the small cylinder, reaches its apex when the middle one is halfway down. So these guys are 90 degrees out of phase with each other. It's an invention back in the 1800s by a fellow named Stirling. And the way it works is that if you heat the bottom plate, the air expands, pushes this up, and through a reasonably complicated interaction between the air between these two cylinders, it actually powers this motor, and or powers this engine. And it has a complete cycle that it goes through. Once per period, it goes through this cycle. The air inside here is exchanged with the air inside the second piston. So these guys are exchanging air, and also there's heat. As you'll see, we're going to heat the bottom surface. That'll be hot. The top surface will be cold. And so there's heat flow from the bottom through the top. So the heat starts here. What I've got is essentially boiling water. I just finished boiling it a little while ago. And I'm going to set this on top of this boiling water, heat the bottom plate, let it warm up a little bit. The Stirling engine has been considered for use in automobiles and other applications. The trouble is, it's hard to get started and to slow down. But once it gets up ahead of steam, it does pretty well. So from your perspective, the wheel is rotating clockwise as it's being heated from below. We imagine the heating up the air near this bottom plate, causing the foam piston to rise, and then exchanging in a complicated manner with the other piston. You can also drive this by cooling from below. So what I'm going to do is to transfer it over to this ice water and see what happens. So now we'll cool the bottom plate so it'll actually be colder than the top plate. Turns out it's a very efficient cycle. This engine is very, very efficient compared to internal combustion and other types of engines. So if one of you scientists or engineers out there can master this for applications, then send me a part of your royalty check. What happened is that it slowed down, and now, as you can see, it slowed down, stopped, and started rotating in the other direction. What's happening now is we're actually heating it from above. There's no such thing as cooling. There's only heat flow. There's the heat or the absence of heat. So the air in the room is hotter than this ice water. So the air in the room is providing the heat that is driving this engine. And the heat flow is from top to bottom, which causes the engine to run in reverse.